welcome back, everybody, and thank you for your patience this week. We're going to move on to 5.2, day 2. 5.2 is going to be divided into 3 units, so we have 2 units of 5.2 this week. We're going to learn how to add and subtract like radicals this week. So first of all, what are like radicals? So like radicals have the same index number, the same index. So if cube roots, fourth roots, fifth roots have to have the same roots, okay? And then they have to have the same radicand. So whatever's under the radical has to be exactly the same, okay? So here's some examples. I could add this square root of x, because they're both root of 2, and they both have the same radicand. Here I can add them because they have the same index of 3, and they both have the same radicand of xy. So I could subtract those. This cannot be done because one has an index of 4, the other one has an index of 3, and they also have a different radicand. So that's what like radicals are, okay? So let's go ahead and put this to use here. When we do these, we have to also, you can't just look at these and say, oh, they're not like radicals, we're done. We need to simplify and see if we can find some like radicals. So the square root of 20, we can simplify because we have 20 would be also 4 times 5, okay? Minus, and then we have a cube root. So we want to try to think of a perfect cube factor that will go into 16, and that would be 8, right? 8 times 2. Plus, and then we're going to also look at a perfect cube factor going into 25, and a perfect cube factor going into, 250, getting ahead of myself, 125 times 2, and then minus the square root of 5, okay? And so you'll notice we have this guy and this guy here that both are square roots, and then we have these two guys here, they're both cube roots, okay? So if I simplify this guy here, this 4 is a square root of 2. So we have square root of 2 square root of 5. And then this one over here is just going to be minus square root of 5. Don't forget to bring the sign with it. That's a negative square root of 5. Okay. And then this pink guy here, this is going to be the cube root of 8. So minus the cube root of 8 is 2. And then we have the cube root of 2 left inside. And then this cube root of 125 is 5. So we have plus 5. And then this 2 stays inside. So the cube root of 2. So now you know why we did all that practice simplifying cube roots, or simplifying radicals. So now we're going to simplify these guys. So when I simplify it, it's just like a variable. So the number out here is in front of here is 1. Okay. And so when I add them like a variable, this would be 2 square root of 5 minus 1 square root of 5, leaving us with 1 square root of 5. Okay. Just like a variable. If I had 2x minus 1x, we'll leave you with 1x. Okay. This is a negative 2 cube roots of 2 plus 5 cube roots of 2, leaving you with a positive 3 cube roots of 2. Okay, so the radicals just stay the same. We're just adding the coefficients together. And that's simplified. I can't add those together any further because they're not like radicals. Okay? All right, let's do one more. Let's simplify this guy. So it's a cube root. So I want to think of a cube root factor that will go into 2,000, and I know that 10 cubed is 1,000. So this is going to be the cube root of 1,000 times 2, right? So plus the square root of 2 minus, and here's another cube root, and a cube root of 128 is 64. And this just takes some practice, you guys. So you have to play around with it and kind of divide, maybe do a factor tree. But this is going to be 64 times 2, okay? And so then I can start to take the roots of these guys. Now I have 2 cube roots and I have 1 square root, okay? So the cube root of 1,000 is going to be 10, and then the 2 is going to have to stay inside the root. So cube root of 2. I'm going to go ahead and bring this guy over here. So minus the cube root of 64 is 4. So 4 cube root of 2, okay? And then plus square root of 2. Well, these two right here, these are like radicals that have the same index and same radicand. So 10 minus 4 is 6 cube roots of 2. And then plus my square root of 2. And that is simplified. Okay, we can't add those any further. Even though we have the same radicand, we do not have the same index. So I can't add those together. Okay? Now we're going to do a little application problem here. This design here shows boards needed for bracing the back of some set scenery. And these are square set sceneries, by the way. Will 75 feet of wood be enough for all of the bracing? So what we're going to do here is I'm going to take this 4-foot bracing here. We need to find the length of a diagonal. So I know that 4 squared plus 4 squared is going to have to equal that x squared. That's going to be 16 plus 16 equals x squared. And so that's 32 equals x squared. Square root, which is 16 times 2, which gives me x. So it's going to be 4 square root of 2 equals my diagonal here. So that's going to be 4 square root of 2 on both of those diagonals. Okay. This guy over here, same thing. We have 7 squared plus 7 squared. And I can use a special right triangle ratio on these guys. If you guys remember from geometry, since this is a square, this is 45, 45, 90, making this just 7 square root of 2. Okay, so I could go through all of this mess, or I could just use my special right triangle relationships. Okay, I can go ahead and follow through with this. It's okay. So 49 equals x squared. This becomes 98 x squared square root. This is the square root of 49 times 2 equals x, and so it's 7 square root of 2. Okay. Now, so now we have our lengths here. So we need to have, let's see, we have 4 here. Whoops, I need my purple. We have 4 here, 4 here, and then I put 7 here. We're not going to add the 4 here because the 7 kind of takes care of that whole side, and 7 here and 7 here. So we need 4 times the 7 plus 2 of the 7 square roots of 2, right? Plus, we're going to need 3 of the 4s right here, around here, and then 2 of the 4 square roots of 2. 2 of the 4 square roots of 2 there. Okay, so this is going to be, we got 28 plus 14 square root of 2 here, plus 12 plus 8 square root of 2. So this is going to be, what's that going to be, 40 plus, and then this is going to be 22 square root of 2. Well, that doesn't really help us to tell us if 75 feet is big enough. So we actually need to calculate what 40 plus 22 square root of 2 is. So I'm going to actually take this 40 plus my 22 and then my square root of 2 and calculate that guy. And it's 71 feet around there. So it looks like 75 feet is going to be plenty big. So this is going to be 71.1 feet. And so that 75 feet of board should cover what we need. Okay. All right. So why don't you guys try this one and see how you do, and then we'll be off and rolling. So here we want to kind of factor these up. These are all square roots. So we'll see what happens when we simplify these guys. So this is going to be 4 times 5. And 100 is a perfect square here. So 100 times 6 minus, and then 25 times 5 is that guy there. Okay. So the square root of 4 is 2. So I have 2 square root of 5. The square root of 100 is 10. So 10 square root of 6. The 6 has to stay in there. Square root of 25 is 5. And the square root of 5 stays in there. Okay. So I can combine these two because it has both square root of 5. So 2 square root of 5 minus 5 square root of 5 leaves me with negative 3 square root of 5. And then I'm left with minus 10 square root of 6. And that is as far as I can go. Okay. All right. So you guys have an Excel in Google Classroom 5.2 day 2. Be sure to show all of your work and attach it to Google Classroom. And I will catch you all on the flip side. Have a good night. Bye-bye.